Welcome to chapter 4. Finally, we are about to apply all the math that we learned in our pre-algebra and algebra courses to chemistry. So we learned about calculations, about conversion factors, converting from one metric unit to another, but it wasn't directly associated with chemistry. Converting grams to milligrams or micrograms could have been done in some other course as well, probably physics. Also, all the significant figures we learned about previously also applies to other sciences as well. Then in chapter 2, we learned about the atom, the periodic table. In chapter 3, finally, we learned about the bonding in atoms to create compounds, the covalent bonding and the ionic bonding. Now we learn some practical skills that are used in the lab, and this will involve a lot of math. However, it's not very advanced math, it's very basic, and it only requires a few math skills, as you will see, but you must be able to do those skills accurately in order to reach the right conclusions. Now we learned about atoms in the previous chapters. Atoms are exceedingly small. You cannot see an atom with your eyes. You cannot see an atom under a microscope. Under a microscope we see things like bacteria and even viruses, but they themselves are made up of billions of atoms. So you can imagine how small atoms are. Atoms cannot be seen with eyes, and they are so small that you cannot put a single atom on a balance in any lab, no matter how sophisticated the balance is, to weigh it. You cannot weigh an atom on a balance. Yet we know the masses of individual atoms for different kinds of atoms, such as hydrogen atom. What's the mass of one hydrogen atom? What's the mass of one carbon atom? And so on. And because the masses are very small, as you would expect, we have come up with a different unit called the atomic mass unit in order to express those mass. Imagine trying to express the mass of one atom. It's going to be less than 1 millionth of a gram, 1 trillionth of a gram, or even 1 quadrillionth of a gram. 1 quadrillionth of a gram is 10 to the negative 15 grams. So if it's less than that, it's better to come up with another unit that expresses those numbers that are more relatable. And that's what the atomic mass unit is. One atomic mass unit is defined as 1.661 times 10 to the negative 24 grams. How much is 10 to the negative 24? Well, 10 to the negative 15 is a quadrillion, 10 to the negative 18 is a thousand quadrillion, 10 to the negative 21 is a million quadrillion, and then 10 to the negative 24 is a billion quadrillionth. So 1 AMU equals taking 1 gram and dividing that into billion quadrillion parts, and one of that part will equal to 1 AMU. That's what this means. Please understand that. You don't have to memorize this relationship. Don't memorize this number, because such numbers you will see again and it would just be too many to memorize. This kind of information will always be provided to you. Now, how exactly is 1 AMU defined? Did some scientist somehow measure this little mass? No, of course not. Like I said, it's impossible to measure such small mass. 1 AMU was actually defined as exactly the mass of one atom of carbon 12. One atom of carbon 12 was defined as having the mass that was equal to 12 AMUs. So nobody isolated one atom of carbon 12. What is carbon 12? Carbon 12 is the isotope of carbon, which has 6 neutrons. Carbon has 6 protons, and this particular isotope, the most common, has 6 neutrons. That's why it's called carbon 12. So one atom of carbon 12 was defined as having the mass of 12 AMUs. And from that point, doing mathematical work led to this conclusion that 1 AMU must then equal to 1.661 times 10 to the negative 24 grams. The masses that you see on the periodic table, if you have a periodic table handy, look at the periodic table. All those numbers, the atomic masses, the only number with a decimal point in it, because the other number is the atomic number. Well, those atomic masses are expressed in AMUs. So what's the mass of one atom of lithium? 6.931. But what is the unit? Is it 6.931 kilograms, pounds, tons? No, it's AMU. So one atom of lithium has a mass of 6.931 AMUs, and so on with any other atom. Carbon has a mass of 12.01 AMU on the periodic table. So that's the atomic mass unit. While atomic mass unit is a step in the right direction, it doesn't allow us to do anything practical in the lab. Why? Because we cannot measure that mass. Regardless of us defining it here, we cannot measure it. We need to come up with a value, a number that's going to be a bridge between the AMUs and grams. Something that allows us to know how many, if a particular amount of certain substance, such as 10 grams of lithium. Well, 10 grams of lithium has how many atoms in it, and so on. So we will look at an example of that in the next we'll look at an example of that in the next video.